The Department of Impact and Waves in Solids studies elastic waves in solids using theoretical, numerical, and experimental methods. Using new methods, we can diagnose materials and structures without damaging or dismantling them. Our aim is to detect the presence and propagation of material defects in time and to prevent failures. The development, implementation and testing of the methods for computer simulation of processes in solids subjected to various types of mechanical or thermal loading are an integral part of our research methodology. Continuous monitoring of structures by the method of acoustic emission helps to detect the initiation and propagation of defects, such as material cracks and leaks from pipes, valves, storage vessels, and other structures. The ongoing damage can be located using piezoelectric sensors and principles of artificial intelligence. Computational methods of molecular dynamics allows us to observe in detail the development of defects at the level of atoms and molecules and to predict the behavior of cracks. The most recent methods of detecting hidden defects in materials include methods of non-linear ultrasound spectroscopy that are up to 1,000 times more sensitive than classical linear methods. The time reversal procedures open up new possibilities of detection of defects and reconstruction of signal sources. We're developing an ultrasonic probe which will allow surgeons to instantly measure the main directions of stress in a particular skin tissue and therefore the most appropriate direction of the incision. Incorrect orientation of an implant can cause complications during healing. The ability of the skin to return to its original state after loading indicates its biological age or current health. The results of dynamic material tests help to shape the use of the materials in many industrial applications. An example may be the dynamic resistance of structural components or biological materials or food during transport. Computer simulations are also needed to understand the dynamic deformation processes in detail. Computer simulations are also an important part of designing modern products and devices. Using our in-house software PMD, based on the finite element method and certified by the State Office for Nuclear Safety, we can predict the behavior, properties or service life of mechanical components. We focus on the problems of the propagation of elastic waves in solids, contact problems in solids, material creep due to long-term high-temperature loading, and the irreversible plastic behavior of metals.